The core pitch for enterprise AI in complex industries like legal, healthcare, or tax is simple. It will save you time by completing specialized work while you sleep. To deliver this, the industry relies on a single interface, chat layered over data retrieval. You submit a prompt and wait for a blinking cursor. The structural flaw here is that chat is a strictly synchronous medium. While the software is processing your request, you cannot step away to do other work. You are anchored to the platform, actively waiting for the agent to finish its response. This setup traps professionals in real-time execution. The economic value of artificial intelligence rests on asynchronous leverage, but requiring a human to supervise a text box negates that completely. Beyond chat, the industry's primary method for establishing trust is the use of citations to verify generated outputs. Structurally, this pushes the entire burden of quality control directly back onto the operator. A professional auditing complex documents against generated citations performs a highly intensive task. The hours required to verify the agent's work match the hours spent doing the task manually in the first place. The initial generation speed is irrelevant. To build viable systems for the enterprise, engineers have to abandon interfaces that require user participation. They must build architectures explicitly designed for delegation. Solving the synchronous trap requires a specific structural model, the Agentic Conveyor belt. Phase 1 of this architecture targets highly repeatable professional workflows that require more than an hour to complete. This schematic shows how the system strips these tasks out of the active user session. By decoupling the heavy computation from the front-end interface, the execution drops onto a parallel track, allowing it to process in the background. Out of the box, an autonomous agent will hit an 80% quality baseline. It will fail to match the hyper-specific formatting and idiosyncratic conventions of individual professional firms. To bridge that gap, the system needs a constant feedback loop. By silently capturing their corrections on the main UI thread, the platform funnels these preferences back to the background agent. This is phase 2. The system observes how a user modifies the output and automatically codifies those specific professional habits to close that remaining 20% gap. Crucially, this skill capture happens invisibly. If you force a tax professional to open a settings menu and explicitly write out system instructions, they will abandon the tool. Pushing intensive tasks to an asynchronous track while absorbing user preferences through direct usage creates the foundation for true operational leverage. Moving execution to the background immediately triggers a psychological problem. When a user loses visibility into how the work is being done, their trust in the system drops to zero. Phase 3 restores that trust. This telemetry dashboard overlay reveals the precise logic traces mapping the agent's internal pathway. Instead of handing back a completed file, the platform exposes every calculation and decision the agent made along the way. A supervisor reviewing the final output can click on any generated number or legal clause and instantly see the exact piece of raw source data that produced it. Without rigorous structural telemetry mapping, professionals will not trust a black box. If they don't trust the data, they will never walk away from their screens. Trust also depends on handling failure. When an asynchronous agent encounters a novel edge case or lacks the context to make an assumption, it cannot guess. Phase 4 is deterministic intervention. The architecture is hard-coded to halt execution the moment it reaches an assumption boundary, preventing it from hallucinating an answer. The user's role shifts from a primary operator to a supervisor. The halted agent sends an asynchronous ping, asking for explicit human resolution on that single conflict. The supervisor responds to the tag, clearing the roadblock so the agent can resume its forward movement. Injecting a correction is as fast as replying to a colleague in Slack. The process restarts, and the user avoids taking over the entire manual workload. There is a secondary safety requirement for high-stakes tasks. Before the system modifies a database or takes an irreversible action, it must generate an explicit plan for the supervisor to pre-approve. Maintaining strict deterministic control boundaries gives the user confidence that they are steering the ship. That confidence cements their willingness to delegate. This architecture has profound business implications. Specifically, it forces us to rethink how we measure the scale of a software product. In the first physical era of business scaling, operations were bound by physical space and headcount. Value creation was strictly limited by the number of human employees a company could hire to execute tasks. Digital transformation shifted this dynamic. Software allowed companies to push the labor onto the consumer. the bottleneck moved away from the employee headcount and fell directly onto the total number of active users actively tapping on screens. The agentic era represents the third phase. For the first time, the structural bottleneck of human time is eliminated entirely. Because the limitation of user attention has been removed, the standard SaaS metrics we use to measure success are now obsolete. This chart tracks the gold standard metric for legacy digital platforms, weekly active users. The goal has always been to maximize time spent in the app, but optimizing for continuous user engagement contradicts the core promise of an asynchronous, agentic product. A more accurate reflection of this system's value is a metric called weekly active sessions. Watch what happens to the data. The active user line actually drops, while weekly active sessions spikes upward. A session is defined strictly as the total volume of discrete tasks completed by the system, combining both the human execution and the autonomous background agents. The expanding gap between those two lines represents pure automated value. Human time spent in the application actively decreases, while the total output generated by the firm scales outward without restriction. The ultimate proof of a successful agentic architecture is this exact metric inversion. It proves that the software is finally doing the work while the user sleeps.